All right, on page 470, we're going to continue to talk about and work with similar polygons. And we want to define this term scale factor. Is the ratio of corresponding sides of two similar polygons. Scale factor is the ratio of corresponding sides of two similar polygons. So if ABC is similar to XYZ, and the scale factor is, let's go with 2 to 1. Now, what's real important here is the order of these numbers in the scale factor and the order in which the similarity statement is written. Without looking at a drawing here, if ABC is similar to XYZ and the scale factor is 2 to 1, that means that the first triangle is twice as big as the second triangle. It means that the sides of the first triangle are twice as big as the sides of the second triangle. Okay? Make sense? Super important. So let's put a little note here. Sides of ABC are twice the size of the sides of XYZ. ABC is similar to XYZ. Scale factor is 2 to 1. First triangle sides twice as big as second triangle sides. So if we have this same bit of information, I'm going to say now if ABC is similar to XYZ and the scale factor is 1 to 2. You see what's changed? Do you see how the numbers in the ratio have changed? If ABC is similar to XYZ and the scale factor is 1 to 2, that now means that the sides of ABC are half the length of the corresponding sides of XYZ. All right? So now we're going to say sides of ABC are half the sides of XYZ. If the first description, if the first polygon is smaller than the second polygon, then the first number in the scale factor is smaller than the second number in the scale factor. The scale factor corresponds to the triangles, to the corresponding sides. If the first triangle is bigger than the second triangle, then the first number in the scale factor is bigger than the second number in the scale factor. Okay? Everybody see that? Thanks. All right, so let's look at real world example 2 on page 470. And Kuma wants to use the rectangular photo shown in the background for her computer's desktop, but she needs to resize it. Determine whether the following rectangle images are similar. If so, write a similarity statement and scale factor. Explain your reasoning. So the first two rectangles we're going to compare. We're going to compare the red one, ABCD, and we're going to compare it to EFGH. All right. So let's take a look at these two shapes. We've got this first rectangle. ABCD. It's a rectangle, so that means all the vertices are 90 degrees. And we're comparing it to this one next to it, or below it and to the right, that's a little bit bigger. And this is EFGH. Now, side BC on the original image is 8, and side DC is 10. On the image we're comparing it to, it's a rectangle as well. So all the angles are congruent. All the angles are 90 degrees. And side FG is 12. And side HG is 14. Now, if you look back in your notes, or if you think back in your notes to last week, polygons are similar if corresponding angles are congruent. All right, that's the first rule. So in this case, since all the angles in the first shape are 90 and all the angles in the second shape are 90, it meets that rule. All the angles are congruent. The second rule for similar polygons is that corresponding sides are proportional. Corresponding sides are proportional. So what we have to do here is we got to write a proportion. And the proportion that I'm going to write is I'm going to do right side over bottom. So I'm going to do right side over bottom. That's going to be my proportion. So look, right side over bottom of the first shape is 8 over 10, isn't it? And we're going to see if it's equal to right side, which is 12, over bottom of the second shape, which is 14. In order for these two shapes to be similar, this proportion has to be equal. So now we're going to crisscross multiply, and we're going to see if it's equal. And 8 times 14 is equal to 112. And 10 times 12 equals 120. So if these two cross products are not equal to each other. And these products are not equal to each other, then the two shapes are not similar. Two rules have to be met. Corresponding angles have to be congruent, and corresponding sides have to be proportional. So now, what we're going to do next is we're going to compare ABCD to JKLM, the other picture in that diagram. So here's our ABCD again. All 90-degree angles. B to C is 8, D to C is 10. Now we're comparing it to that other rectangle, JKLM. We've still got 4 90-degree angles. So we know corresponding angles are congruent. Now K to L is 12. M to L is 15. Are the shapes similar? So I'm going to use right side over bottom again. Right side over bottom, 8 over 10, and I'm going to set it equal to, or I'm going to see if it's equal to, right side of the second shape, which is 12, over bottom of the second shape, which is 15. So I'm going to crisscross multiply. 8 times 15 is 120. And 10 times 12 is 120. So look what we've got now. We've got corresponding angles that are congruent. We've got corresponding sides that are proportional. So it meets both criteria to be similar polygons. If so, write the similarity statement and scale factor. So again, we're going to write the similarity statement. And I'm just going to start in the upper left corner of this first rectangle, and I'm going to go clockwise. So I'm going to say that ABCD is similar to, if I start in the upper left, I'm going to start in the upper left of the second shape, and I'm going to go clockwise. JKLM. So ABCD is similar to JKLM. And our scale factor is the ratio of corresponding sides. So look, our scale factor is equal to, I can use the 10 over the 15, or I can use the 8 over the 12. I can use either ratio. I'm going to use the 8 over the 12. All right, and I have to write it in simplest form. The scale factor has to be in simplest form. So our scale factor, 8 over 12, 4 goes into both of these, right? So 4 goes into 8 twice, and 4 goes into 12 3 times. So ABCD is similar to JKLM, and the scale factor is 2 to 3. And again, this numerator, this first shape is smaller than the second shape, isn't it? If the first shape is smaller than the second shape, then the numerator needs to be smaller than the denominator. Okay? All right, so let's look at the guided practice on the bottom of page 470. Guided practice, determine whether the two triangles shown are similar. If so, write the similarity statement and scale factor. Explain your reasoning. So here's our first triangle. And we've got NQP. N has one arc mark. Q has two arc marks. N to Q is 12.5. And NP is 15. Second triangle. A little bit smaller. Triangle RST. Angle R has one arc mark. Angle S has two arc marks. R to S is 10. S to T is 9.2. And T to R is 12. P to Q is 11.5. Okay, so first, let's address the angles. We've got two angles in one triangle congruent to two angles of another triangle. If two angles of one triangle are congruent to two angles of another triangle, aren't the third angles congruent as well? They have to be. All right, so we know by rule that all of the angles are congruent. Now what we have to do is we have to pick corresponding sides. And I'm going to pick the side that goes from one arc mark to two arc marks. So right here, one arc mark to two arc marks, one arc mark to two arc marks, over the side that goes from two arc marks to three arc marks. So 2 to 3 and 2 to 3. So as far as arc marks are concerned, my order is 1 to 2 and 2 to 3. So when I write my proportion, this 12.5 is going in the numerator. I'm going 1 to 2 and 2 to 3 over 11.5. And I'm going to see if that's equal to, in this right triangle, I'm going from one arc mark to two arc marks, so that's the 10, over two arc marks to three arc marks, and that's the 9.2. So I'm going to crisscross multiply and see if these two are equal. All right, 12.5 times 9.2. I get 115. And we're trying to determine if that is equal to 11.5 times 10, which is 115. And those two are equal. So what we've got here, we've got corresponding angles that are congruent. We have corresponding sides that are congruent. Corresponding sides that are proportional. So we're going to write our similarity statement. And in this similarity statement, I'm going to start with one arc mark to two arc marks to three arc marks. So I'm going to call it triangle NQP. Is similar to, and we're going to go 1, 2, 3 in arc marks again, RST. Now our scale factor is equal to, I'm going to use the 1 arc mark to 2 arc mark side, the 12.5, n to q. N to q is 12.5 over n to q corresponds to r to s, and r to s is equal to 10. All right, and just be careful here, because when we're writing our scale factor, we can't have fractions in the numerator or denominator. All right, and we have to be in simplest form. So the first thing I'm going to do is double this numerator and denominator, and look what I get. If I double the top, I get 25, and if I double the bottom, I get 20. So 12.5 over 10 is equal to 25 over 20. And then I'm going to take the 25 over 20 and simplify it. It's easier to simplify than 12.5 over 10. So 5 goes into 25 and 20, so we get 5/4. So similarity statement. Scale factors 5 to 4. And if you had to explain your reasoning, you could say corresponding angles are congruent and corresponding sides are proportional. And in your practice today, if you're asked this same question, write the similarity statement, write the scale factor, and explain your reasoning. You could maybe just put an asterisk by this explanation, and instead of writing all this out every time the shapes are proportional, your explanation could just be the asterisk, right? And the asterisk means that the corresponding angles are congruent and corresponding sides are proportional. All right, so that's what you're going to be doing today. And then tomorrow we're going to use rules about similarity to find side lengths in proportional shapes. So your practice for today is going to be on page 472. Do problems 3 and 4. And then on page 473, do 14 and 15. And obviously it's a short week, so notes and practice tomorrow, study guide Thursday, quiz on Friday.